morning, everyone. My name is Molly Tenbrook, and I want to thank you all for joining us today for our webinar. Today's webinar will focus on UVM Framework. Before we jump in, I would like to give you a brief introduction to Trilogic and what we do. For over 30 years, Trilogic has provided software and services enabling engineering groups to design, develop, and deliver products through excellent support, training, and consulting services to help you achieve success sooner. Oasis Sales has been a mentor premier partner for over 16 years. Their industry knowledge and experience make them uniquely qualified to understand your business and how technology will make their customers successful. As you see here highlighted on the map are the regions that each Oasis and Trilogic cover. Here you can see the different design and product management areas that Trilogic covers. You'll notice we've tried to create a suite of products that will provide a front-to-back solutions all the way from concept to end of life. Make sure that you're subscribed to our YouTube channel as well as Oasis Sales YouTube channel. Here you'll find our recorded webinars as well as some demos. And make sure that you're also following our other social media channels like LinkedIn, Facebook, and Twitter. And now I would like to introduce today's presenter, Walter Goody. Walter has over 25 years of experience in ASIC and FPGA design and holds an MS in electrical engineering from Washington University in St. Louis. He worked for 6 years doing ASIC design at Tel Labs operations. From there, he went to work for Mentor Consulting, where he consulted on various ASIC projects, including time spent in München, Germany, and Helsinki, Finland. For the last decade, Walter has worked as an applications engineer supporting Mentor's line of functional verification projects. Please welcome Walter.
I want to welcome everybody to the webinar today. As Molly said, I work for Mentor Graphics, and I support the basically FPGA and ASIC design front-end tools. So today's webinar is on the UVM framework. And what we'll do is we'll talk about the UVM in general. What is it? Why do you want to use it? And then, what is the UVM framework that's built on top of the UVM, how it will benefit you in jumpstarting creation of your UVM test benches. Then we'll talk a little bit about some of the other technologies that are integrated with UVM. And finally, we'll show you a quick demo of the UVM framework. So the UVM. UVM is super powerful methodology for creating your test bench. The whole point of UVM is that it allows you to work at a much higher level, at a transaction level, so that your tests, your scenarios are generated at a higher level, which means you can do more interesting things. There is randomization, which helps with uncovering bugs that you never thought about. So it's good for bug hunting. Lots of benefits of the UVM. So if you look at a UVM environment, the base object in a UVM environment is called the agent. And so an agent for every major communications port, let's say you have a USB port, let's say you have a PCIe port, a generic bus transfer port, you're going to create an agent for each one of those ports, and that will handle the communications of that port. And so that agent will have basically within it, it will definitely have a monitor, it will probably have a coverage collector, and then if it's an active agent, it will get sequences from your test. That will be a sequence of transactions that you want to send on that port that comes over to the sequencer, which hands it off to the driver. The driver passes those sequences to the interface connected to your DUT and basically turns that high-level transaction into bit wiggles. So everything up here is happening at the transaction level, and then everything down here is then happening at the signaling level, at the bits wiggling level. Like I said, one of the benefits is that you get to look at those transactions. I did an AXI read with these parameters over this period of time. That's a lot easier to debug than to look at a bunch of wiggles on a line, especially for something like a two-line interface, like a PCIe interface. You're talking thousands and thousands of bit wiggles on two lines, and you've got to figure out what that is. So then on the opposite direction, when something happens on this bus, this monitor observes that signal and turns it back into transactions. Then in your UVM environment is where those agents live. You might have a reference model that says, if I put this stimulus on, I expect to get this result back. So that's the reference model. You might have a scoreboard, coverage collectors. You're going to have to configure each agent. You're going to have to configure maybe your register models. So there's a lot of code that goes on when you talk about that. I talked about coverage. So if you start to look at all the code that gets generated for every one of those agents, this is all the different files to create one of those agents. It's about 15 different files. These are probably a couple of hundred lines each. And so every agent, you end up with all of that code, a couple of thousand lines of code for each one. Your environment has a few dozen different files. Your tests have a bunch of files. So you start to look at all the code that you have to create, and it starts to feel kind of daunting. But the secret is most of that code is fairly common and fairly boilerplate. So you could either copy it over from a different project and then just make the changes that you have to, but that can be a little bit error prone. So, this is the joke I like to give, is that, if you start with just doing lab testing and then starting to do a little bit of simulation, you start to do code coverage, you start to do assertions, but then taking that last leap to doing the UVM is pretty daunting. It takes an object-oriented coding expert, somebody with experience already oftentimes, and it's kind of a giant leap that is hard for most places to take. So that's where the UVM framework comes in. What the UVM framework is a set of UVM code generators, meaning that instead of having to write those 15 files for each agent, what I can do is create from a template. I can say, what are the IOs that I care about? What are a few other things? And generate all that code. So it's a set of code generators for each of your agents, for your whole environment, for your test bench, and for your first test that you're going to run. So you can generate that code rather than write it from scratch. So you can go from taking a week to taking a couple of hours. So it's really meant to be a jumpstart, and it's meant to be a methodology where we've really kind of thought through a lot of the pitfalls that new users end up facing the first time they're doing a UVM environment. If you think about System Verilog is, the enabler, it's the tools, the raw materials that are allowing you to do this. UVM is kind of, the next level up. It is, let's put some structure around that UVM code. Let's start to give you the framework to build your house, say. UVM framework is, okay, now what we're doing is we're saying, a room is a certain thing. It's got a doorway, it's got a window, it's got outlets. So let's just build that in. And UVM framework allows you to generate those prefab pieces. And then what you do is you create verification IP, which becomes reusable from project to project, or maybe from block level to system level within a project. So it's kind of this base that we're building that all up out of. So there is a UVM framework user guide that comes with the UVM framework. UVM framework, by the way, is open source, meaning it is Apache licensed. There's no purchase cost for it. Basically, when you install Questa, you get the UVM installation directory. And then there is this user guide in there that, has a bunch of examples, walks you through them. There's a code generation guide as well, but I'll show you some of that stuff. So why generate the code, I've already kind of talked about. For each one of those agents, there's 2,000 lines of code. For my environment, there's another 500 lines of code. For a test, there's a few hundred lines of code. So by instead taking the common things, like, I'm doing this for a mem, so I'm going to, basically just have that piece in there. This is the code. So there's some common things like I'm going to have a mem, which means I have a mem configuration, a mem driver, a mem monitor, et cetera, et cetera, et cetera. So those common things, those bit widths, those things like that, I put those into a template of my code, and I use that to generate the piece. So there's two different ways that you can create that template. The original way was using Python scripts. We can still accept the Python scripts, but then we also, if you're familiar with YAML, once you start to learn it, it's a little less wordy than the Python template, and what happens is you create a YAML template, which spits out the Python template. Honestly, I have a lot more experience with using the Python template, and this is kind of an example of one. So in this particular one, the name of the thing that I'm generating is called the FPU register agent. I say what the clock and the reset are. I tell what all the inputs and outputs are, and these are inputs and outputs from the test bench's point of view. So the input to the floating point unit is an output of my test bench. The result coming back from the floating point unit is an input to my test bench. So I say, what are the ports on my thing? Maybe I put in some things like, I'm going to have some instructions. I'm going to do an add, multiply, subtract, divide, square. I'm going to have a couple of different rounding modes. So I created a couple of types for those. And then those ports that I declared up here, I want to come down here and say those are internal variables for the class, and am I going to randomize those? So I create that template, and then I pass it to this code generator, this Python code generator, and it spits out those 15 files for that agent that I showed. But on top of spitting out those 15 files, which is the package declarations, the class definitions, the interfaces, all those things, it also spits out the make file and all the file lists that are going to be needed for compiling all that code. So I do one of these for each agent. I do one for my environment and one for my test. So if I have two agents in my environment, I would create two agent templates, one environment template, one test template. Those 4 templates, it would spit out a complete UVM test bench. And then what I have left to do as the user is to go in and edit a few of those files to make them more interesting. What comes out is actually a runnable test bench. It just doesn't do a lot yet because there are a few tasks that I need to do. So the first task I need to do is say, let's go into the driver, and it puts in this generic access task, and it even puts in a little comment that says, this is some place that you're going to want to come in and do your changes. So I replace that generic access task with a do write task and a do read task and a few other things. So I do that. The monitor, I do a similar thing to that. I'll go in and put some constraints in my class to kind of configure how the random generation is going to happen. And then I go from the base test that gets generated, I extend that and create new tests around that. And so I end up then with a full UVM test bench. This is the directory structure of everything. I'm not going to talk to this slide a little bit. Just kind of point out that each one of the agents is going to have its own little package down here. I can then create an environment. I can instantiate one environment within another. These are all reusable things. These project benches, that's specific to my particular project. That's kind of where we split this. The verification IP is things that I might reuse, and the bench is something that's just for this one project. So the whole point of the UVM is to accelerate your test bench development, to get you running a UVM test bench way faster than you could ever do it by yourself. we've thought about the pitfalls and all the things that say, I want to pick this agent that I created for this project up, and I want to use it not just at the block level for this thing, but I want to use it at the system level. I also want to pick it up and I want to use it in a different project. So we've thought about the pitfalls of the reusability and the scalability and everything. So this is just demonstrating that here I've got an agent that's an SPI agent and a Wishbone agent, and I can create that environment, and then I can instantiate one environment inside of another. So a lot of folks have used this. We have, I think that says over 30, I think it's more like over 50 different companies now have picked up and used the UVM framework. And my experience has been that in some cases, with people with a little bit of experience, I was just able to do a WebEx with them for a couple of hours, show them the ropes, and they were off and running with no more help. Other customers who weren't quite as advanced, we can do like a half-day workshop on site to help you get jump-started. Both ASIC and FPGA customers, we have Verilog system Verilog customers, we have VHDL customers, and we've seen a broad adoption across a lot of different companies. A couple of the other technologies that are built into here, the verification IP, Mentor sells a set of verification IP. So for certain standard things like AXI, PCIe, USB, Ethernet, for a lot of the standards out there, we already have UVM agents, so verification IP built on UVM agents, and there is a configurator, and that's been merged into this technology so that you can bring in those pre-existing pieces of verification IP. Verification management, so all of our test plan checking and tracing to your test plan, et cetera, is integrated, our verification run manager. So we've definitely looked at that. Again, here's some of the possible ways that you can get started. Have kind of a little bit, it's not totally a canned seminar yet. We still are kind of tweaking it, but we can come in and do a half day on site to get you jump started. We can work with you to get your first agent or two created and up and running. A few different ways we can help you get started. And then from a support standpoint, there's myself as the AE support. We have a UVM field support expert named Bob Oden, who, for the right customers, I can get Bob involved, and he is much, much deeper than I am. We do have a training class that's available for mentor training. If you have a huge project and you have a fast deadline, we can get mentor consulting involved. And then Bob is actually teaching a class on UVMF at North Carolina State University right now. And so I think he's in the process of creating a textbook, and we'd like to believe that, there'll be a lot of universities doing that class fairly soon. The summary is UVMF is a proven infrastructure. It is built on Bob Oden's and several other, Jonathan Kraft, a few of the other AEs. It's kind of built around their best practices, and so that's all incorporated into the code that gets generated by the UVMF generator. We hope that it helps jumpstart your UVM development and helps you to not run into a lot of the reuse roadblocks that we have seen over the last few years. So right here is the 4 templates that I use to generate my UVM. So let's just take a look at this one here. And you'll see this is the template that I started to show you earlier. It's for, loading up the registers of the FPU in order to do a floating point operation. So the name of it is FPU bus. I set the width there, I set the clock and the reset, and then I've got a few IOs right here. So for every operation I'm going to do, I'm going to load up input A and input B, I'm going to load up what operation I want to do and what type of rounding I am looking for. I load up those things. I send the start signal, and then I wait for the ready signal to come back, and I read the result register. So that's all the ports of my FPU. I created a type that was just a type def for add, subtract, multiply, divide, and square. So my operation is 3 bits, and there's 5 different operations I can do. And then my rounding mode is either near, 0, round up, round down. So I've got the rounding mode. And then basically these ports right here, I've come down and I've said, okay, input A is going to be randomizable, and I want that included in my automatic comparison checker that gets created. Same thing with input B, the operation, the rounding mode. I've got a few internal bits. You'll see the result comes back from the FPU, so I'm not randomizing that, but I do want to include that in my comparison. And then a few other internal variables that I'm using. So I've got those variables. I run that through the script, which is literally, I say Python and then this template name, and it dumps out all of the UVM code. So let me come up here and right here, yeah. Okay, so what this is showing is right here is the output of those template generators. So when I ran my FPU bus template generator, it generated all of this code right here. So it generated these 20 files. So it generated the agent, it generated a driver, it generated a monitor, it generated a transaction thing, it generated a bunch of type defs, some packages, and a make file to compile that agent. And then what you'll see over here is this is the code that came straight out of the code generator. Over here is I took that directory and I copied it to another location, and I did the changes that I needed to make it a functional test bench. And what's highlighted in red are the files that I made changes to. So you can see of the 20 files that got generated, I really only made changes to 5 of them. And the changes are fairly simple. For the driver BFM, I got rid of this generic do transfer task, and I replaced it with a task that, this was the generic task, and it was just saying, okay, what operation am I doing? What kind of rounding mode? Let's put the inputs on the thing. Let's clock them in. Let's wait for the ready to come back, and let's sample the result. So basically, I changed it from that generic task to that. On the monitor side, I did a similar thing that I just took out what was this generic monitor, and I said, okay, let's look for that start signal. Let's sample the outputs. Let's find everything. Let's then sample the result. So, I mean, honestly, it's some fairly simple changes on that driver and monitor. This base sequence was what was generated, and then I created a test that was an extension. I took and extended that base sequence into this particular test where I was just going to send some different transactions to my design. Look at one last thing. And then basically on the bus package, all I did was I added that sequence that I created. So then on the generic bus thing, it was very similar changes that I did. And then on the environment, all I did was I actually added a predictor and I added a UVM register model. And so you'll see I just had to add those packages to there, and I had to make a few updates to the environment to include those 2 packages. And then this makefile right here will compile the agents and then compile the environment. So you see it's a fairly limited number of changes that I have to make, and then I end up with at the end, I did not do anything other than the changes I talked about, and I can just see make debug, and that is going to run through, compile my entire test bench, launch the simulation, and get me up and ready to be running this UVM environment. So we'll see that I ran through the code generator. I did that make file. You'll see my entire environment has been generated. I've got my environment that has my FPU bus agent. It's got that generic agent. It's got my the generic agent there. It's got my scoreboard. It's got the reference model that I instantiated. And you actually see over here that when I loaded this design up, it automatically added all the waves for all of my transactions and for my register block and all the I/O into and out of my FPU. So if I actually go and run this, microseconds, say, that I actually do get, I can see that I did a generic read of this address right here on the MPU. I wrote in those things to that register. Here's the operation I did. This particular test bench, I'm only doing one operation right now, but you'll see it automatically added all of this stuff to the wave window to basically get me not only a fully operational test bench, but everything I need to start debugging that test bench as well. I think we can wrap it up.
Okay, great.
Right.
Thanks, everybody.
Thank you, everybody. Goodbye.